So, if you remember back the beginning of the last videos, I told you that we were actually going to figure out two big groups we could put our chemical reactions into, right?
Yes.
And then we didn't tell you yet.
No.
Because we had to know how to do oxidation numbers to figure out our two big groups. Because our two big groups, we said, are those that involved transfer of electrons and those that didn't. We track that with oxidation numbers.
Okay.
So, when we do our oxidation numbers, we can figure out if they've changed, electrons have been transferred. If they don't change, electrons have not been transferred. If our oxidation numbers change and our electrons have been transferred, we call them redox reactions. So our redox reactions are just things that involve transfer of electrons. The reason it's redox is it's smushing together reduction and oxidation. So they're oxidation reduction reactions or redox. No, I don't know why they switched the order. All right, so reduction occurs when things gain electrons, and oxidation occurs when things lose electrons. So, is that what we expect?
Well, no, because generally if there's a reduction, you're reducing something, you should be getting less.
Right, so what we have to watch out for is actually what our oxidation and reduction are talking about is how our oxidation numbers change. So if our oxidation numbers get smaller, so if you look at the reaction we have over here, this, by the way, is what we call a half reaction, because we're not showing everything that's going on, we're only showing the part we care about. So when chlorine picks up an electron, we say it's reduced because its oxidation number went from what's chlorine by itself?
Chlorine by itself is, if it's by itself, okay, it's a free element by itself. Free elements are zero.
So free elements are zero. It picks up an electron, and now its oxidation number is what?
-1.
Now it's -1. So it's gone from 0 to -1. It went down. It got reduced.
Okay.
So the counterpart to reduction is oxidation. So sodium, if you look, has lost an electron. Its oxidation number started as?
It also started as 0, we're saying. So we're saying it's a free element.
Right.
Okay. And then it lost the electron right here.
Which gives us a?
It made the charge go to +1, so the charge went up.
Right. So oxidation is losing electrons. Reduction is gaining electrons, but your numbers go down. That's what you're looking for.
Okay, so let me just get this straight. If we're talking about the numbers, reduction is the oxidation number is going down.
Yep.
Okay, and oxidation, the oxidation number is going up.
Right.
Okay, so that's what we want to think about so we can keep them straight. I like that a lot better.
Yeah,
Okay.
It's a lot easier to deal with. All right, but what you do need to remember with our electrons being transferred is our electrons can't just spontaneously appear or disappear, because that would violate what? What law?
Law of conservation of mass.
Right.
Right.
Electrons don't weigh much, but they weigh enough they can't just vanish. So electrons lost by one element, so during oxidation, have to be picked up by another element, reduction. They have to happen at the same time. Do not try and tell us that only one thing's being oxidized and nothing else has happened, or two things are being reduced and nothing else is happening. You have to have both.
So if something is being reduced, so its charge is going down, something else has to be oxidized, so its number has to be going up.
Right, because your charges
Okay.
have to be the same on both sides total. So if something had a charge that went down, something has to have a charge that goes up, so it still adds up to the same thing. It's like algebra. You have to do the same thing on both sides.
Okay. Oh, you know what this kind of sounds like? It kind of sounds like balancing.
A little bit.
We have to make sure that we have the same number of elements on both sides, So we got to make sure that our charges
Our charges work out
are
on
the
both
same
sides. Yeah.
on both sides. Oh, that's kind of neat.
Mm-hmm.
Okay. Okay.
So there are a couple different ways that you can help you remember this, and it gets a little tricky anyhow. But one of the ways you can remember is Leo the lion says grr. So if you think back to what we just talked about on the last slide, what do we think that Leo is telling us?
Okay. So if I'm
The easy parts are E's. What were our E's talking about?
the E's are the E's are the electrons.
Right.
Okay.
So what happens to our electrons?
Well, so some electrons are being lost.
So
some of them are
losing
being,
electrons.
Okay. So here's, and we said losing electrons. Is oxidation.
Is our oxidation.
That was our definition.
There you go.
Okay. I don't know how to spell Miss Copeland. Well, I don't know how to spell oxidation. I think I know how to spell Miss Copeland. Maybe I'll find out later.
All right.
Okay.
So then, if losing electrons is oxidation, what's GR telling us?
Okay, so that is probably gaining electrons is reduction.
There you go.
Even though, okay, yeah, so gaining electrons is reduction, and that's making the charge go down.
Right.
Awesome. Okay.
All right. So we told you at the beginning of this video that there were two types of reactions in the world: those that are redox and those that aren't. And actually, all of our reactions that we've already classified, we can tell at a glance if they will be redox or not based on what type we already know they are. So we know that combustion takes oxygen by itself and puts it into a compound, which means it's got to change the oxidation number. So combustion is always redox.
Okay. Combustion is always redox.
All right? Single replacement reactions take something by itself and put it in a compound. Also, always redox. Anytime you see single replacement.
Single replacement, also always redox.
Okay? Decomposition and synthesis. You're taking two things and smashing them together, or taking one thing and pulling it apart. Oxidation numbers will change. Synthesis and decomposition, always redox reactions.
Decomposition and synthesis, always redox.
So, what do you notice? What haven't we put into one of our groups yet?
Well, we haven't talked about double replacement.
Double replacement. Double replacement, all that's happening is two ionic compounds are trading partners. Nothing is changing with electrons, so double replacement reactions are never ever redox.
And so that's the other. That's the only one.
That's the only one. If it's double replacement, it's not redox. If it's something else, it's redox.
Well, that's kind
So we're gonna still have to get into how we figure out what's being oxidized and what's being reduced. But those are a nice handy dandy reference to figure out if you're gonna have to.
Oh, that's good to know.
The reason we spent so much time in the last section assigning oxidation numbers to our substances is because that's what's going to tell us if electrons have been transferred and if our oxidation numbers have changed. So let's go through and assign our oxidation numbers first.
Okay.
So, which parts of this are going to be really easy to assign oxidation numbers to?
The free elements, I think we could probably do.
Right, so the free elements are really easy. What are the free elements always?
The free elements are always 0. So I can say I've got magnesium is going to be 0.
Uh-huh.
And can I go ahead and assign oxidation numbers on both sides?
Yeah.
Okay, so I can look hydrogen. Hydrogen's by itself. And I can write a 0 because it's also the free element.
Right, so remember, even if it's a diatomic element, since it's only got one element, nothing else, it's still 0. All right, so what was our next rule down that we can deal with?
The next rule down was the assign the oxidation number by the periodic table.
Right, so we're going to look at the
Okay.
charges on our metal.
Okay, so that means my metal is magnesium.
Yeah.
Okay, so magnesium on the periodic table is in group 2, so it is +2.
All right.
Okay.
So next.
Hydrogen. I can look at hydrogen.
Uh-huh.
And hydrogen is always +1. So I've got a hydrogen right there. So
Uh-huh.
I can say it's +1.
Awesome.
Okay.
And now we've got SO4. So for regular, we are not dealing with polyatomic ions. For pre-AP, we will deal with it, but an easy hint for both groups. If you've got any polyatomic ion that stays exactly the same on both sides, nothing in that polyatomic ion has been oxidized or reduced, because if it had, it has to change. So for right now, we're going to actually ignore our polyatomic ion because it's exactly the same on both sides, so nothing interesting has happened there.
Oh, that makes sense.
All right, so since we can ignore our polyatomic ions, what does that leave us to look at?
Okay, so then in that case, I'm looking at the change between the magnesium and the oxygen. No. That's hydrogen.
Yes, so we have magnesium and hydrogen.
Okay.
So one thing that can help is to actually write down at the bottom what we've got and what happened to it. So
okay, so we've got magnesium.
And what happens to its oxidation number?
Let's see. On this side, it was 0.
So write that it was 0.
Okay, so
and then
0.
arrow.
Okay, and then
because when it reacts, it goes to what?
It goes to positive 2. So
positive 2.
Positive 2.
All right, now let's do the same thing with hydrogen.
Okay, so we've got hydrogen.
All right, and so it started out at?
It started out at +1.
Okay.
So I put +1.
And that's going to go
to over here on the product side, it went to 0. So it went from +1 to 0.
All right.
Okay.
So remember, if we think back, we're trying to identify what is oxidized and what is reduced. And remember, reduced was easier to see once we were looking at our numbers. If it's reduced, what's happened?
If it was reduced, let's see. Leo, the lion, says Kerr. The R is reduction, gain electrons. So,
okay, so right now, don't freak out about the electrons. The electrons are good, but don't get too bogged down. If we look at this,
oh, I see.
We're trying to look for what's reduced.
Right.
So we've listed out what happened to our oxidation numbers. Which one's been reduced?
Okay, the +1, the hydrogen has been reduced because it went down from +1 to 0.
It went down from +1 to 0. And yes, that happened because we gained electrons, because that's what reduction is. But what you need to look for, did my number go down? Did my number go up? If your number went down, it's reduced. So hydrogen in this reaction is
okay, so
reduced.
hydrogen was reduced.
Right. So if hydrogen was reduced, what do we know has to happen to magnesium?
Okay, so if we have to have oxidation, since they have to be together, so that means magnesium was oxidized.
Right, and we know that also because our oxidation number went from 0 to +2, so our oxidation number increased. The other way we know that is because to go from 0 to +2, you've got to lose electrons, and oxidation is loss.
So maybe an easier way to think about it, if I have, like, on my practice, if I have to answer which one's oxidized and which one is reduced, focus on the charge, focus on what happens to the oxidation number.
Yeah, you still need to know that oxidation is loss, reduction is gain, but if you're trying to identify what's happened to what, look for your oxidation number changes.
Okay.
All right.
That kind of makes it easy.
So if you think you figured it out, pause, work on your guided practice. If you're not quite so sure, hang out with us. We're going to do a couple more together.
All right.
Okay,